Hello everyone. In this lecture we will discuss the mean and variance of a continuous type random variable in a distribution. In the previous lecture we have discussed the mean and variance of a discrete random variable in a distribution. Now in a continuous distribution, as we know, in a continuous distribution the random variable varies continuously. Random variable varies continuously over an interval, right, over an interval. It cannot specify for a single point, right. Now the usual form of a continuous random variable is like this, where the density function is specified or known, and here suppose in some interval a less than x less than b, it is suppose your f1x. Some interval c less than x less than d, suppose it is your f2x, and it is 0 elsewhere or otherwise. In fact, suppose if we think of an exponential distribution, f of x is equal to, if I say some theta e to the power minus theta x, x is positive, means here the interval is 0 to infinity here, the interval is 0 to infinity here, and 0 when x negative. That means the interval is minus infinity to 0. That means the continuous random variable varies continuously over an interval, right. If I talk about the value of the variable at a particular point, means it is meaningless, right. Now coming to the distribution of this function, if we talk about the distribution of the function, probability distribution function, just I recall you, or we call it the cumulative distribution function, right. It is PDF, capital PDF, and this was here small PDF, okay. So now means if we talk about the distribution of f at some x, so what does it means? Means the probabilities of 2 here x, means we integrate the density function from minus infinity up to x, and whatever the probability density function is known to you, right. This is what the distribution function of a continuous random variable. Now coming to the properties, if we think of these properties, your integral minus infinity to infinity fx dx is here 1, capital F. If we take here capital fx dx is of course 1, because the sum of the probability function is here 1, and this will be nothing but my probability of minus infinity less than x less than here infinity, is not it. So if we talk about probability of a less than x less than b, already I have told in my earlier lecture, to make it independent to some extent, I just recall this thing, means it is your fb minus fa, is not it. So that means your integral a to b fx dx, right. Since we don't bother about the probability at a particular point, so less than and less than equal to make no difference in continuous case. If we talk about probability of x less than a, means here up to a, minus infinity to a f dx. If we talk about probability of x greater than a, so what does it mean? Integral a to infinity here fx dx, or if you think it in the sense of the complementation, 1 minus p of x less than equal to a. Likewise, if you ask, if I ask what is f of minus infinity, exactly it is in the limiting sense, limit some x tends to minus infinity f of x, right. It is nothing but here minus infinity to infinity f dx, already I have told you it is 0. Similarly, if I think of f of infinity, it is here f of infinity is here 1, right. Now if we think of the relation between here the density function and the relation between the density function and the distribution function, here d by dx of fx, right, fx is here fx. Now fx being the probability function, it is positive, So that's why it has to be positive, or rather we can say since 0 is there, is non-negative, therefore we can say fx is non-decreasing, right? It is non-decreasing function, non-decreasing function. So these are the properties of, these are all the properties of distribution function or cumulative distribution function in continuous random variable. Just I reviewed all these things. Now let us come to our main thing, what we are supposed to discuss, the mean and variance. So before discussing the mean, let me to generalize this mean by telling you what is a mathematical expectation here. Mathematical expectation, right? Likewise in the previous lecture, here phi x be a continuous function here, right? Now the expectation of phi x be a random variable as usual, x is a continuous random variable, with associated period, associated probability density function is your fx. So now this will be in minus infinity to infinity phi x fx dx, right? Now if I remind you the continuous discrete case here, in discrete case what we have studied? We have studied it summation of phi x, phi xi, fxi, we have studied it. So now in continuous case it is integration, means here we are just replacing the summation by the integration, what we discussed in the previous lectures, right? Now the moment, now coming to the mean, now the moment here x is replaced, phi of x is replaced by your phi of x is replaced by your x, then this expectation of x, now it converted to expectation of x, it is nothing but my mean mu. It will be simply minus infinity to infinity x into f of x dx. It is called mean of the random variable x in a distribution, in a given distribution, right? Or talking to this, it is nothing but the expectation of x, mathematical expectation, or simply the expectation of x. Already we have discussed this thing in discrete version in our earlier lecture. Now coming to the moment, the moment of a random variable, x with respect to or about a specified real number r, a is given by expectation of x minus a to the power some r, right? This, so here r is a non-negative integer, so means the phi x is replaced by this here phi x is replaced by x minus a to the power r. So this will be my integration minus infinity to infinity, here x minus a to the power r fx dx, right? And we can denote it by mu r a, right? Now the moment, now coming to the central moment, now the moment this specified real number a is replaced by, the moment a is replaced by the mean mu, then your moment it leads to central moment, right? It leads to central moment. That means my expectation of the central moment is expectation of x minus mu to the power r, is not it? So, this is equal to my integral minus infinity to infinity x minus mu to the power r f of x dx. Likewise, the notation here will be mu r mu, or we may simply write it mu r, right. So, if we talk about what is your mu 0, if we talk about what is your mu 0, means it is minus infinity to infinity x minus mu to the power 0 f dx is nothing but integral of f dx over the interval this. So, this is nothing but my sum of the probability is 1. So, in that way. So, if I talk about what is your mu 1, so mu 1 will be here 0, integral minus infinity to infinity x minus mu f dx. Okay. So, this is integral x f dx minus mu is constant taken out, integral of f dx from limit of integration minus infinity to infinity. So, now is it not your mu, and it is your minus mu into 1. So, this is equal to 0. So, therefore, my mu 0 is is your 1, and your mu 1 is 0. However, mu 2 is called, however, my mu 2 will be my second order central moment, right, second order central moment, which is the variance, right. The second order central moment is known as the variance. So, what is your variance? So, variance means it is denoted by sigma square or VAR of x or also V of x. So, it is nothing but my second order central moment means x minus mu whole square, right. If you write it in terms of the integral, it is minus infinity to infinity x minus mu whole square fx dx. It is your second order central moment or the variance. The moment we talk about the standard deviation, it is your sigma. So, sigma is the positive square root of the variance of x, right. Now, talking about the relation between mean and variance, right, mean and variance. It is expectation of your sigma square is expectation of x square minus expectation x whole square, or we can write it expectation of x square minus mu square. If we want to prove it, sigma square is expectation of x minus mu whole square. So, this is equal to your expectation of, you open it, it is x square minus 2x mu plus mu square a minus b whole square, and apply the properties of expectation. It is individually expectation of x square minus twice mu expectation of x plus expectation of mu square, right. So, this is your expectation of x square minus twice mu, this is your mu, expectation of constant is constant, right. So, now you add these two. So, this is your expectation of x square minus mu square, is not it. So, therefore, your sigma square is expectation of x square minus mu square is proved. Now, come to some solved examples, some important problems we will discuss, solved examples. So, let us discuss some important problems here. So, coming to an example, if the random variable is of continuous type and the probability density function is given like this, you are asked to find what is the value of k and what is mean, what is variance and the standard deviation of this distribution. Now, coming to the value of k, you know the integral minus infinity to infinity fx dx is 1, sum of the probability is 1. So, you integrate it. So, this is minus infinity, look at this interval, it is minus infinity to 0, plus 0 to 1, then plus 1 to infinity, right, here f dx. f dx, but in first and third integral, so it is elsewhere case, otherwise case, it is elsewhere case, so it is 0 obviously. So that means my integral 0 to 1, the function here is within this limit, it is this. So k is taken out and you just multiply it, it is your x minus x square e to the power x, right, e to the power x dx. We integrate it. At this stage I tell you, recall you a easy way of integration. If one is your exponential function u into v, one is your algebraic and other one is exponential, then you can split it, u integral of v minus derivative of u and double integral of v, put a positive sign, twice derivative of u and 3 times the integration of v, minus you continue, plus minus continue up to this till the derivative term 0, right. If you apply this way of integration, then you can easily integrate, otherwise you have to apply by parts twice. So this implies you integrate it k, right, and first x minus x square remains silent, it is e to the power x, put a negative sign, the derivative of this 1 minus 2x, the integration of this is e to the power x, put a positive sign, the derivative of this is only minus 2 and the integration is e to the power x, and it is integrated, the limit is here 0 to 1, right. So this implies, and this value is equal to your 1, so your k, and this will be your putting 1, it is your 0, putting 1 here, it is 1 minus 1 e, plus putting 1 here, it is your e, putting 0 here, first term is 0 and putting 0 is here again minus minus, plus e to the power 0 is 1 and putting 0 plus twice e is equal to 1. So you simplify it to get k into 3 minus e is equal to 1, implies your k is equal to 1 by 3 minus e. Now with this k you find now mean. So what is mean now? Integral 0 to 1, right, actually minus infinity to infinity, it is x into f dx, but in otherwise interval it is 0, so it will exist only in this interval here, right. So this is equal to, you substitute the value of k, so it is integral 0 to 1, the function is kx 1 minus x e to the power x, kx 1 minus x minus x square e to the power x into one more x will be multiplied here, this is not it. So this is x square minus x cube e to the power x dx. If you integrate likewise, you will find it here k into 3e minus 8, you now substitute the value of k, okay. So it is here 3e minus 8, the value of k is 1 by 3 minus e. So this value is 0.5496, where e value is 2.7182, right. With this you have this value. Now accordingly, first we need expectation of x square in order to find your sigma square, because what is your sigma square? It is your expectation of x square minus mu square. So accordingly you find integral 0 to 1 x square into f dx, okay. So this is equal to integral 0 to 1 x square into k into kx into 1 minus x dx, right. So this is equal to, taking k outside, integral 0 to 1, it is x square into x cube minus x fourth, some e to the power x is here, e to the power x dx, and you just simplify it, you just integrate it, and it will give you k into 30 minus 11e, substitute the value of k, 30 minus 11e divided by 3 minus e. Therefore your sigma square is expectation of x square minus mu square, already you got the mu, right. You find the value, it will be your 0.5 04904. Okay, then coming to the sigma, it is the root over of this, then it will give you 0.0422, 0.2214. So expectation of x square, if you substitute the value of v, it will be this much, and accordingly your sigma square and sigma. Coming to one more example, find the mean and variance of the uniform distribution, right? It is a standard distribution also. You may remember the probability density function here. So what is the PDF for this probability density function? Here f of x is equal to 1 by b minus a less than x less than b, right? And it is 0 elsewhere. So you want to find the mean of the distribution. What is your mean? Mu is integral minus infinity to infinity x f dx. So this is equal to your a to b. Elsewhere it is 0. It is x into 1 by b minus a, x into 1 by b minus a dx. So 1 by b minus a taken out, it is here x square by 2, the integration of x from the limit a to b. It is here b square minus a square by 2 into b minus a. So this is equal to b minus a into b plus a divided by 2 into b minus a. So this is equal to a plus b divided by 2, right? So mean of this uniform distribution is a plus b by 2. Accordingly, you have your sigma square is expectation of x square minus your mu square. Likewise, you can solve it. Integral a to b x square into 1 by b minus a dx minus mu square is here a plus b by 2 whole square. Okay, let it be silent. You just go on solving and it will give you finally b minus whole square divided by 12. Now coming to some important problems. Example 3, find the mean life of a light bulb whose life x in hours. How many hours the bulb will last, and the density is given like this. Okay, and you have to find what is the mean of the life of the bulb, how long it will last here. So your fx, can you not say it is of the form some k e to the power minus kx, right? Your x is positive. So by default here saying x negative time, so it is meaningless. So in this interval by default f is 0 here. Okay, it is understood, so not being specified here. Now it is asked what is the mean life here. K is known, k is here 0. For simplicity we write it. Now what is my mean mu? Mean mu is integral minus infinity to infinity here x into fx dx, is not it? So this is only valid in the interval 0 to 1. So this is 0 to 1 k, it is here x e to the power minus kx dx. You apply the by parts here and you integrate it. After by parts, this will give you k, and it is x e to the power minus kx by minus k. Put a negative sign, the derivative of this is 1. It is e to the power minus kx by k square. Okay, 0 to 1. So this will give you sorry, it is the 0 to infinite. The limit of the integration is 0 to infinite, is not it? X greater than equal to 0 is given. So here this integral, this first term will not valid. Okay, So this is equal to here k by k square into here e to the power minus infinity is 0, it is here 1. So this is 1 by k. So the value of k here is 0. So this is 1 by 0.001. Now this is here 1000 hours, is not it? 1000 hours, right? So therefore the mean life of the light bulb is 1000 hours under this given density. Coming to one more example, a small filling station supplied with gasoline every Saturday afternoon. It is being filled in every Saturday afternoon. Assume that its volume of cell x, the random variable is the volume of cell, in 10,000s of gallons, right? The unit here is 10,000s of gallon. So cells has the probability density is this. Determine mean, variance and standardized random variable, right? Mean and variance is as usual, right? And the standardized random variable is a new thing here. So as usual, what is your mean mu? So mean mu is as usual, integral minus infinity to infinity x f dx. It will not work here, minus infinity to infinity will work only in the interval 0 to 1. So this will be integral 0 to 1, 6x into 1 minus x, one more x is there, x dx, right? And if you simply integrate it, this integration will give you, with this limit, this will give you 2 minus 3 by 2. So this is equal to your half. So you find likewise expectation of x square. It is 0 to 1 x square into f dx. Again you find here sigma square is your expectation of x square minus mu square. It is as usual. So if you simplify it, if you integrate it, it will give you 3 by 2 minus 6 by 5. Now you substitute it here. This is expectation of x square minus mu square, half whole square. So it is 0.05, means 1 by 20. Now coming to the new thing, what is the standardized random variable? The standardized random variable is z is x minus mu divided by sigma, right? Accordingly, if it is asked what is the expectation of this, you will be able to find it. And what is the sigma square variance of z, you can also able to find it, right? Now here what is the standardized? Of course your expectation of z, if you work out it, it will here 0, and your variance of z is here variance of expectation of z. If you solve it, it is expectation of 1 by sigma taken out, it is x minus mu. This is equal to your expectation of x minus expectation of mu is your 0, and if you find sigma square, it is your 1. Okay. So now what is the standardized random variable here then? Then you just substitute the value of z, x is your x, mu already we got it, mu is your half divided by sigma, sigma is 1 by 20 sigma square. So coming to sigma, and then it will be root over of 20. So this will be the value of the standardized random variable, right? The mean and variance are not asked, but I told you, since it is a standard thing, what is the mean and variance of the standardized random variable. Coming to the last problem, last example, the mileage in multiples of 1000 miles, okay, after which a tire must be replaced. After 1000 miles the tire need to be replaced. So it is given by the random variable with density function is this, right, in x greater than 0. So but here the tire will last negative time is not permissible. So by default it is 0 in the remaining interval. So what mileage can you expect to get on one of these tires? Okay, how long the tire will last? Moreover, it is given theta is 0.04. You find the probability that the tire will last for probability of x greater than equal to 40,000. If I take 1000 40,000 miles, means I can say x greater than equal to 40 in thousands of miles, in thousands of miles, in thousands of miles. In that way we will find it. So let us first find what is the mean of this. So, your mean here is integral minus infinity to infinity except dx. So, it is only in the positive integer. By default f is 0 here when x is negative. It is not permissible in the negative interval, because the as far as the life of the tire is concerned here. So, if you integrate it, it is 0 to infinity theta e to the power minus theta x. Likewise, in the example 3, so here you will get it 1 by theta. So, what is the value of theta now? The value of theta is here 1 by 0.004. So, in the question this theta is given 0.04, okay. So, 0.04. So, it will be here 4 by 100 means 25, it will be here 25, right. Now, the next question is asked, probability of x greater than is equal to 40. So, what does it mean? Integral 40 to infinity. So, 40 to infinity permits here with the same, right. It is the probability distribution here, simply fx. Here we are not finding the mean, here we are finding mean, we multiply, here we are finding the distribution, right, fx dx. If you integrate it, it will give you 40 to infinity theta e to the power minus theta x dx, right. If you simplify it, this is theta taken out, theta by minus theta e to the power minus theta x 40 to infinity. So, this is minus of 1 minus this is theta by theta e to the power minus 40 theta e to the power minus 40 theta. So, this is here e to the power minus 40 theta, okay. Now, here this is e to the power minus 40 into the value of theta is 0.04 is e to the power minus 1.6, okay. So, this will give you 20.18, means approximately here 20%. So, the question was that find the probability that the tire will last at least 40,000 miles. So, the probability is 20% that the tire will last at least 40,000 miles, okay. The video is getting lengthy, so we will close here. Thank you all. In the next future study, we will discuss, we will discuss 3 important distribution: Poisson distribution, binomial distribution, Poisson distribution, right, Poisson distribution and hypergeometric distribution. These are under the category of hypergeometric distribution, these are under the category of discrete distribution. Again, coming to the continuous distribution, we will have here normal distribution and here exponential distribution. So, you sequentially will discuss all the major important distributions. So, thank you all.